Hi, we are Nancy Garcia and Daniel Avila, and we're going to talk about the ping pong game created using an FPGA program using a hardware design language. And to give a little background for this project, we use the Max 10 Lite FPGA from Intel, which is a programmable device where we can design the behavioral circuit multiple times within the same device. And since this is a soft processor, we can add or remove the peripherals that we use at any moment of the development process.
Okay, as we can see in the pictures, we use the VHDL hardware design language. At the top-down design methodology, we can divide the methodology consists in dividing the problem in very small pieces or small boxes that contain only perform a specific task. Well, this methodology makes the design process easier because it facilitates the debugging process when looking for any errors or improvements. When we have those little components by their own, we can interconnect them in a top-level entity.
So here's a quick demonstration of the ping pong game using the VGA screen using the Max 10 Lite. And to achieve this, we applied all the theory learned from the last semester. That means the use of logic gates, flip-flops, multiplexers, and coders. With information related to the communication with the monitor using the VGA ports that is provided in the manual of the Max 10 Lite, we have a lot of information inside that help us to start designing the entities or components that will make this game possible. We know the synchronization signals, or coordinates that or values of each axis that indicates where to draw something in the screen or not. And something that is very important is the pixel clock indicated, which is 25 megahertz. And since the Max only has 2 of 50 megahertz and 1 of 10 megahertz clocks, we can use one of the 50 megahertz and divide its frequency.
The controller also contains two counters. One counter increments on pixel clocks and controls the timing of the horizontal signal. It equals the pixels column coordinate during the display time. We use two 10-bit counters to create the one mode 800 and one mode 525.
So here is the RTL from the both state machines from the x-axis and the y-axis, and it's the outputs are the synchronization signals to the screen, and also the two signals that allow us to know where we can start drawing or not. And here are the state machines from the y-axis and the x-axis.
To drawing, we generated a hardware test image with some codes that using the coordinates of position of the paddle that uses the coordinates. This VHDL takes the pixel coordinates and display enable signals from the VHD controller to output color values to the correct times in red, green, or blue.
Here is an entity that changes the score of each player when the ball reaches the edge of the screen in the horizontal axis, and those values go to a coder that sends an output signal from the 7-segment display.
The last part is the movement of the blocks. Well, the palette movement logic refreshes the frame each time it reaches the limit, or don't, using the vertical coordinates because the movement is merely vertical, but the ball moves in both directions. Well, the counter increments in 1 by when it hasn't reached the limit, and it reduces by 1 when it has to bounce back.
And here is the final RTL diagram of the top entity level with the small components interconnected, and the only output signals are the synchronization signals and the RGB colors.